Okay, welcome Math 20-3s to Chapter 3. This chapter is going to be looking at surface area and volume, and our first lesson is going to be looking at the surface area of prisms. Okay, so surface area is a two-dimensional amount of space, and these shapes below are going to be what's making up the surfaces of all the objects that we're going to be looking at. So the first one, we have an orange square, a blue rectangle, a yellow triangle, and a red circle. So just to remind you of how to calculate the surface area of these, for the square, it is going to be this side times this side, which is base times height, but because they're the same thing, it's just going to be their sides times their sides, which is side squared. So that's the formula there. Area is equal to that side squared. For the rectangle, it's again, you multiply those two dimensions, but we call this the base and this the height, and area is equal to base times height. A triangle is similar. It's kind of like half of a rectangle. If you put two together, you would get a rectangle. So we have its base multiplied by its height here, and then we just divide by 2. So A is equal to B times H divided by 2. The circle is the one that's kind of a lot different than these. How we measure kind of the dimensions of a circle is with radius and diameter. Radius is from the center of the circle to the edge, and diameter is 2 radius. So it's like the whole width of the circle would be the diameter, and it's the same as r times 2. And the formula that we're going to use, or the formula that is used for calculating the area of a circle, is area is equal to pi r squared. And all these are going to come in useful. And now we're going to look at prisms, so three-dimensional objects, and look at their total two-dimensional surfaces and how that adds up to their surface area. So if we take all these objects, we're going to look at the three-dimensional versions of all of these. And it's going to be their prisms. So this is a square prism, which is also called a cube. This is a rectangular prism, and this is a triangular prism. This is a sphere, but today we're going to be focusing on these three and how to calculate the surface area of those. So starting with a square, when we're considering all of the surface, we kind of think of like how you would undo or like take apart this 3D object so it was laying flat on two dimensions. So I had to think of it, this is the top, and then there's a bottom side under there, and then there's 4 surfaces wrapping around this way. So first imagine if you like cut this like it was a cardboard box, and you cut all the edges, and you laid it out. I'm going to look at these 4 surfaces first, and you'd lay them out like that. They'd all fold down. And then when you fold the top and the bottom out, they would kind of go on like that. So there's 6 surfaces. There's 4 sides, a top, and a bottom. So I'm just going to label here. This would be the top. This would be the bottom. And I'll just put side, 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 side. Now we just need the surface area of all of these squares added up together. And fortunately for the cube, they're all the same dimensions. So if I'm focusing on this side here, we take this length times this length, and we get our surface area. And all of these 6 sides are the exact same. So we just need, looking at the 3-dimensional diagram now, switch to another color, this times 6. So it's gonna be side times 6. So for example, if it was something like, let's go 4 centimeters, we would go 4 times 4 is equal to 16 centimeters squared for each of those 6 sides. Then we times that by 6 to get our answer of 96 centimeters squared. It still says centimeters squared because we're still looking at two-dimensional space. We're looking at volume in a couple lessons from now. Now a rectangular prism is going to unfold really similar, except there's going to be variation in the side lengths. So this one looks kind of like it's a square on the end, but it doesn't have to be. So this length could be different than this height. And let's just say that it is. Let's say that this is 6 centimeters and this is 4 centimeters right there. And then this dimension is also going to be different as well. That one looks pretty long. Let's say that's something like, I don't know, let's go with 20 centimeters, something like that. So now when this unfolds, we're still gonna have 6 sides, and they kind of come in pairs of 2. So this front is gonna be the same as the back, right? You can't really see that, it's on the side part there. The top is gonna be the same as the bottom, which you see underneath, and the 2 ends, but end and end, are gonna be the same. So it kind of works out that you can see the top, front, and one end, and then they all have an equal one on the other side. So let's unfold this. I'd start with like the front, the top, the bottom, and the back, and it would kind of look like that. And I've just shown these to be equal, which it could be for a square. Let's imagine that they're not, and then we're going to use the dimensions that I drew. Then we're going to unfold the ends, which would go right there. So quickly I'm going to label those dimensions on there. So we said that this was 6 by 4, and there's going to be 2 of those. So I'll keep these in red for our ends. Then we're going to have our front, which I'll show in green here, and our back right here, and those are going to be 4 by our length of 20. And lastly, the top and bottom are about right here. So this is the top, this is the bottom, and those dimensions are 6 by 20. So we have 3 different sized sides, and now we just have to calculate each of those and add them all up. So I'm going to start with the side with 6 times 4, or the end, and that is 24. There are 2 sides, so we double that to be 48. That's my total for the sides. Next, looking at the front and back, we have 20 times 4. That equals 80, but again, there's 2 of them, so we have 160 for the front and back. And lastly, the top and bottom are 20 times 6, which is going to equal 120, but again, there's 2 of those, so that's 240. So now we just need to add these all up together. I'll go to maybe a blue here, hopefully you can see that. Let's put these 2 together first, so that's going to be 300 and 400, and then add the 48, and we get 448 centimeters squared as our final answer. So definitely a little bit more complex than the cube because we could have some more variation in there. Just make sure you notice kind of like the pairs and what the dimensions for those are, and then set up 3 equations like this. If this side right here was a square, then all of your 4 sides would be the same, which would be kind of nice. Okay, looking at the last one, which is a triangular prism, there's a lot of variation in this. It could have all different sides, it could have all the same sides, you can have 2 the same and 1 different. Just for this example, let's say that they are all different. This might not necessarily be to scale, but we're gonna make some easy numbers. So let's say this side was 10 centimeters right there. It's a 10 on a 16. Maybe this one is 12 centimeters because they look pretty close. Say the bottom is something like 6 centimeters there, and it tells you the height is something like 8 centimeters. Again, it might not be proportionally correct, but we're just making up some numbers. Now when we apply it to this, which is the unfolded triangular prism, we have those 3 sides going around like this, and the 2 at the front and back kind of folding out. We have some rectangles here. We have to track what those dimensions are. So I'm going to take this side here in red and put it right there. So that's going to be 12 by, it has to also tell us this dimension. Let's say that was 10 centimeters as well. Actually, let's give something different. Let's say 14, just so we don't get mixed up with the 10 over here. So that's going to be 12 by 14. The next side over here in green, that's going to be on this side. So that is, again, this 10 centimeters here, and it goes back 14. So let's put the 14 right there and the 10 right here. And lastly, we'll deal with the orange. Let me get the orange one here. For the bottom side, that one is going to be 6 by 14. So you can see the 14 here and the 6 there. Last, we just have to deal with the front and back. We know this is a height of 8, and we know this length here is 6. So a little bit complicated to visualize it going on there. Hopefully you're able to follow it, and now let's just do the calculations of those. So let's look at red here first. This is 12 times 14 equal to 168. That's the only one of that size. Let's do the next one. How about the green one? That one is 14 times 10. And that is equal to 140. Let's go to orange next. That was 14 times 6, which is 84. And the last one, we have the front and back. These 2 are identical. I know I showed them in black there, but let's go to blue here. You might be able to see it a bit better. Our base, which is 6, our height, which is 8, divided by 2. So 6 times 8 divided by 2. However, it might be easier to simplify this that we have 2 of these sides. So we're gonna have to times by 2 anyway. So it just becomes 6 times 8, which is 48. So let's add these up. Maybe I'll put these 2 together first, which becomes 308. And then when I put these ones together, that becomes 132. And then when I put those together, then we get 440. So I'll make that a little bit easier to see here. 440 centimeters squared for our last one. So that's it for this lesson. Ask any questions in the live time, and I will see you in the next video.